Hello everybody. I have a birthday candle here in my hand, and what I'm going to do is take this birthday candle and cut it in half with a micro spatula. Just kind of slice through it. Okay. And I'm gonna put half of the birthday candle into a plain test tube, like that. And I'm gonna put the test tube in a rack, but I'm gonna light a burner that we have here. I'll light a match, get the gas going, and bring the match up to the side of the burner, like that. And I'm gonna hold the test tube into the burner flame like that. And let's begin to watch what happens with the candle wax. Looks like it's beginning to liquefy. And I could continue to add heat to it, but that's pretty much what we want to see. Kind of smooth, solid, and you could see what it looks like. So I am applying a little bit of heat to the bottom of the candle, and I am going to secure it to a glass square. And then I'm going to light the candle like that. And we will watch the candle burn. So we had a candle, a birthday candle lit earlier. This is what's left of it. Nothing. Nothing. Barely any wax. Nothing is there. Here I have a watch glass. A watch glass is a round, concave piece of glass that is often used for scientific experiments that we could do stuff in that would allow us to observe what is going on. I have a sheet of paper, plain white paper. And I'm going to begin to tear the paper up into tiny pieces, like so. And I want you to begin to think about what I am doing while tearing the paper, and what kind of a change that is. Ordinary white paper, what is that doing to its composition, to what it is? So I have a tiny pile of these white pieces of paper that I have piled up onto the watch glass. And I am then going to bring a match up to them and light them. Like this. Let's begin to watch what happens as I hold a match to them. This is a common measuring device we use for measuring small or large volumes of liquid that we call a graduated cylinder. I'm going to use a squirt bottle to add 5 milliliters of water to it. Like so, and if you look at the liquid level, notice there is something that we call a meniscus. It is like a concave shape on the surface of the liquid, and we always want to read the liquid from the bottom of that meniscus. Okay, so we don't do experiments in graduated cylinders. We often do them in a piece of lab equipment that we call a test tube. So I'm going to take the water and pour it into a test tube. And then to the test tube, I'm going to add a micro spatula. This is a micro spatula of sodium chloride. Do you know what sodium chloride is? It's a chemical that we often call salt, ordinary table salt. I'm just going to take a scoop of sodium chloride, table salt, and add it to the test tube like that. And swirl it. To ensure it mixes. Okay, so this is the test tube that we have added the sodium chloride to the water. And notice how clear it is. It looks like ordinary water. So I'm going to put it back into the test tube rack, but into that test tube that we have added the sodium chloride to already, I'm going to take this solution here that is silver nitrate, and I'm going to add 10 drops of silver nitrate to it. I'll pull it out with a dropper, and notice the clarity of this solution inside of the dropper, and I'm going to begin to add 10 drops. I'll count out loud, and you could count along with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the silver nitrate, the solution that I just added, is stored in a dark brown bottle because silver nitrate is sensitive to light. It does not like being exposed to light, so we store it in a dark brown bottle to preserve it. What I have now is a piece of elemental metallic magnesium metal. Notice how shiny it is. The shininess we often refer to as luster. It is very malleable, meaning I could readily bend it. It's very flexible. And if I apply enough stress to it, say where I try to fold it in half and crease it, I can actually break it into various pieces like that, which is what I want to do. Break it into small pieces, and I'm going to add these small pieces of it to a test tube like that. So to our magnesium, I am going to add some hydrochloric acid, which I have prepared already in this bottle here. Couple things about the hydrochloric acid. The 6.0 m HCl, that is a measure of its concentration, which technically means 6.0 molar. That's a measure of its concentration, but that's something that we will study later on in the year. Hydrochloric acid is a relatively dangerous chemical that we handle. That's why it clearly says wear your goggles and why we store it in small bottles like this that have a tiny dropper that allow us to safely use it in small amounts. So I'm going to begin to add drops of the HCl to the magnesium like that. And we should begin to see a change taking place. If I feel the side of the test tube here, it's very, very hot. Hot to the touch. I cannot grab it. So I have added some more hydrochloric acid to this test tube. And notice there is no more solid elemental metallic magnesium. It is completely gone. it has completely reacted inside of the test tube. So all we are left with is a solution. All of that solid metallic metal is gone. Okay, our next reaction. Here I have a chunk of copper 2 sulfate pentahydrate. It is a royal blue solid colored crystal that I'm going to drop into a mortar. And I'm going to take a pestle and begin to grind it up. Break it down into smaller pieces. Like that. And when you begin to break it down small enough, you could begin to grind it into even smaller and smaller pieces. So you end up with a powder that looks like that. Compare to the solid crystal. So here I have the ground up copper 2 sulfate. I'm taking several scoops of it and I'm dropping it into a test tube. Like this. Now, I'm going to take that test tube and I'm going to heat it with a pair of test tube holders. That's what these are. They are used for grasping a test tube and heating it over a burner flame. And I'm going to apply some heat to it, like that. I'm going to make sure the open end of the test tube is not pointed at anybody. And I'm going to apply some heat to the copper 2 sulfate that has been ground up. And you should begin to notice a bit of a change. Okay, so now notice what we have in the test tube, what it looks like. But let's go back and compare to what we started with. Here is the ground up copper sulfate, and here is the chunks of copper sulfate that we started with, compared to what we just heated. So notice here is our test tube that we have just finished heating. Notice the condensation, the droplets of water that have gathered around the top of the test tube, evidence that moisture is trying to be released. But what I have now is a dropper bottle of water that I'm going to begin to add to the test tube, to the contents in the test tube. Drop by drop. Well, and again, notice the color change that we begin to see. Here I have a test tube of elemental sulfur. Notice the sulfur. It is a yellow colored powder, powdery substance. It is solid, and that's what it looks like. It's a yellow colored powder. Next up, we have a test tube of iron, metallic iron, gray, dull gray. But something that you probably know about iron is that it is metallic. So if I take a magnet, a tiny magnet, and draw it along the side of the test tube, you could see I could pull some of the iron up, the iron powder up along the side of the test tube. Sulfur, on the other hand, is not magnetic. I cannot draw any of it up along the side of the test tube. So now let's say we take these two test tubes of these two chemicals and we mix them into one test tube. If I do that, I have this. I have an iron sulfur mixture. Notice the color. You could see little flecks of yellow, which would be the sulfur. You could see little flecks of gray, which would be the iron. But some things you should know that are different between the iron and the sulfur is that iron is magnetic and sulfur is not. So if I take the magnet I had before and I hold it up to the side of the test tube and I begin to draw it up the side of the test tube, you could see it pulls only the iron with it, because iron retains its magnetic property. So here I have our iron and sulfur mixture that we looked at before. I'm going to take this mixture and heat it over a burner flame. If I do that, I end up with this. Notice the difference that this looks like. And if I take our magnet and hold it up to this, it seems like I cannot draw any iron out of the mix. It is not magnetic at all.